A 20-inch shark bit a hole in a nuclear submarine. Not a scratch, not a scrape. A clean, perfectly round crater carved into the sonar dome of a US military sub. And when the Navy pulled records, they found the same circular wounds on dolphins, great whites, sperm whales, elephant seals, and tuna, all across the Pacific. The animal responsible glows in the dark, and it is far from the only one. Roughly 76% of all creatures in the deep ocean produce their own light. 3 out of 4 animals down there are glowing right now, in water so dark that sunlight has never reached it. The deep ocean is not the empty black void you were taught about. It is the biggest light show on this planet, and the things these animals do with their glow are so strange, so violent, and so creative that scientists still cannot fully explain how any of it evolved. That submarine shark we just talked about? We are coming back to it. But first, you need to see the animal that turned glow into a killing machine, because what it does in total darkness is the reason you will never think about the deep sea the same way again. The anglerfish has a fleshy rod fused to the top of its skull, almost like a fishing pole built straight into bone. At the tip of that rod dangles a tiny bulb packed with millions of glowing bacteria called photobacterium. The fish feeds them, shelters them, and in return those bacteria keep the bulb lit around the clock. Now put yourself down there. You are a small fish. You cannot see your own fins. You cannot see up, down, or sideways. Nothing exists except blackness in every direction. And then, out of nothing, a faint glow appears. One tiny dot of light floating in hundreds of feet of pure emptiness. What do? You swim toward it. Of course you do. It is the only thing you can see. And the second you get close, a mouth wider than your entire body opens and swallows you whole. The anglerfish never moves, never chases, never burns a single calorie hunting. It just dangles the light and waits. Dinner walks right in, every single time. But that is not even the strangest part of this animal. Researchers at Cornell sequenced the bacteria living inside anglerfish bulbs and found something nobody expected. Those bacteria have lost 50% of their genes. They cannot make their own amino acids. They cannot break down most nutrients. Without the fish, they are dead. And even though anglerfish evolved around 100 million years ago, those bacteria are still losing genes right now, still getting stripped down generation after generation, and nobody can explain why it keeps happening. They are being slowly erased from the inside out, and they just keep glowing anyway. That is glow used as a weapon. But the next animal takes the exact same chemistry and does something that should be impossible. It vanishes right in front of them. Deep-sea predators hunt by looking upward, scanning for dark silhouettes against the faint light trickling down from the surface. Every fish above them casts a shadow. Every shadow is a target. So the lanternfish erases its own shadow. It carries rows of tiny light organs called photophores along the underside of its belly, and those organs produce a glow that matches the exact brightness and color of whatever light is filtering down from above. And these fish adjust that glow in real time, brightening or dimming as conditions shift overhead. A predator staring straight up sees no outline, no shape, nothing at all. The lanternfish disappears by becoming the light itself. And this is not some rare trick pulled off by a handful of deep-sea oddballs. Over 240 species of lanternfish exist, with a combined global biomass estimated between 550 and 660 million tons. That is several times the entire world fisheries catch. They might be the most abundant vertebrates on the entire planet, and every single one of them runs this disappearing act every day of its life. During World War II, sonar operators kept detecting what appeared to be a false ocean floor that moved up and down throughout the day. It baffled military crews for years. That phantom floor turned out to be billions of lanternfish migrating between deep water and the surface, their swim bladders bouncing sonar signals and fooling military equipment across the Pacific. But the glow does even more than hide them. Each species of lanternfish has its own unique arrangement of photophores on its body, like a fingerprint made of light. In total darkness, with no landmarks and no colors, those glow patterns act as the only way for lanternfish to recognize their own kind and find mates. Scientists now believe this is actually why lanternfish branched into over 240 different species, because glow itself became the force that drove their evolution. Now, you have seen glow used to kill. You have seen the glow used to vanish. But what you have not seen yet is an animal that broke every single rule about how bioluminescence is supposed to work. Back to the shark that bit a submarine. The cookie-cutter shark measures about 20 inches. It weighs almost nothing compared to its targets, and it regularly attacks animals that outweigh it by a factor of 10,000, including sperm whales, orcas, megamouth sharks, blue marlins, and the rubber sonar domes of U.S. Navy submarines. How does something that small go after something that massive? Thousands of photophores cover the cookie cutter's entire belly, producing a vivid green glow so intense that Guinness World Records lists it as the most bioluminescent shark on Earth. That glow stays active for up to 3 hours out of water, bright enough to read a book by. All that belly light does the same counter-illumination trick the lanternfish uses. It erases the shark's silhouette from below, but there is one spot on the cookie cutter's underside that produces zero light. A dark band, right behind the jaw. Surrounded by vivid green on every side, that unlit strip creates a shape that resembles a small fish silhouette when viewed from below. So a dolphin, or tuna, spots what it thinks is an easy meal. It charges straight toward the shadow, and the cookie cutter strikes before the prey even understands what just happened. Suction cup lips seal airtight against the skin, upper teeth lock in as anchors, and bandsaw-like lower teeth twist and carve out a perfectly round plug of flesh, leaving behind a clean circular crater. Marine biologists have found these craters on the bodies of whales, seals, marlins, and even other sharks. Just stop and think about that for a second. Every other bioluminescent predator in the ocean uses glow to attract prey. The anglerfish dangles a light. Smaller fish use glow to lure plankton. That is how bioluminescence has always worked, across thousands of species for hundreds of millions of years. The cookie cutter does the exact opposite. It uses the absence of light as the lure and the light itself as camouflage. It is the only known animal on Earth that hunts by making itself dark in one spot and bright everywhere else. Nobody expected that kind of strategy from a shark the size of a bread loaf. And what happens every spring off the coast of Japan makes everything else in this video look quiet by comparison. Every year, between late March and early May, billions of firefly squid rise from over 1,000 feet deep in Toyama Bay to spawn near the surface. These squid are 3 inches long. They live for exactly 1 year. They spend most of that year alone in deep, open water. But when spawning season hits, the females return to the same shallow bay where they were born. And the coastline transforms. Photophores cover their arms, their head, their entire mantle. When millions of them gather near shore at the same time, the bay turns into a pulsing electric blue display you can see from the beach. Fishing boats from Namerikawa drop nets at 3 a.m., and when the catch spills onto the deck, the boats themselves glow blue. The town built the world's only museum dedicated to this one species. Sightseeing boats take tourists out before dawn just to watch the water pulse with living light. And those squid are not lighting up randomly. They flash specific patterns to attract mates. They fire sudden bursts to blind predators. They use belly photophores to match moonlight and erase their shadow from below. One animal, 3 inches long, 12 months to live, running 3 completely different survival strategies with the same glow at the same time. Then they lay their eggs and die. Every single one of them. The bay goes dark, and 1 year later, their offspring return to the exact same water to light it up all over again. So if glow is this useful, how many times did nature actually come up with it? Because the answer is the kind of number that changes how you see biology forever. At least 94 times. That is how many separate, independent inventions of biological light a 2024 Smithsonian study found across the tree of life. Not 94 species share the same glow gene. 94 completely unrelated groups of organisms, animals, fungi, and bacteria, all figuring out how to make light on their own. The oldest origin traces back roughly 540 million years to marine invertebrates called octocorals, nearly 300 million years earlier than anyone believed. And they do not even use the same chemistry. Fireflies run on one type of luciferin. Glowing plankton use a completely different version. Fungi operate on a pathway based on caffeic acid that shares nothing with either of those. One glow molecule called coenterazine shows up in 11 different animal groups, from jellyfish to deep-sea fish, but many of those animals do not even produce it themselves. They absorb it through food, which means the same light-powering chemical passes through the food chain and ends up inside creatures with zero connection to each other. And the Hawaiian bobtail squid runs what might be the most precise glow deal in the entire ocean. It houses bacteria called Vibrio fischeri in a belly organ that glows blue at night, matching the moonlight above and hiding the squid's shadow from predators below. But every morning at dawn, this squid dumps 95% of those bacteria. Why throw away your own light source? Because the remaining 5% get fed all day, multiply back to full strength, and by sunset, the glow clicks back on. Those bacteria even count their own population using a system called quorum sensing, only switching on their glow genes when they hit roughly 10 million cells per milliliter. 2 completely unrelated species running a synchronized daily light cycle at that precision for millions of years straight. Vampire squid blast predators with glowing mucus. Brittle stars rip off their own luminous arms and crawl away while the predator chases the decoy. Sea cucumbers tear off glowing body parts and stick them onto nearby fish, turning random bystanders into accidental targets while the cucumber disappears. Every single one of these strategies runs on the same reaction, luciferin meeting oxygen, releasing light. And nature invented it 94 separate times, in 94 completely different ways, across creatures that have absolutely no business glowing at all. In a world of permanent darkness, where sound fades and vision fails, the ability to make your own light turned out to be the single most repeated survival trick in the history of life on Earth. And what we have found so far is barely a flicker compared to what is still waiting down there. If this one grabbed you, hit subscribe so you do not miss what comes next. The video on your screen right now goes even deeper into the strangest creatures the ocean is hiding, so tap it before you scroll away.